Hello everyone, welcome to the online class of Physics class 10. So today we'll be starting one new chapter number 13, magnetic effects of electric current. So in this chapter basically we'll learn about the magnetism, the field and how the magnet works, magnetic field and magnetic field lines. Then we'll learn about the solenoid, means which is generally an electromagnet, and we will learn about the electric motor and whatever principles and theories related to it are there. So first of all there comes magnet. So magnet is such a piece of stone, or you can say like it's a element which has the property to attract to any iron surface. Magnet attracts to a magnet and has the property to get attracted or to attract a piece of iron towards it. The first idea of magnetism means magnetic and electric field, like whenever we have any magnet there is some electric field related to it, or electricity and magnetism is related. This idea was first given by Hans Christian Ørsted by one of his experiment. What he did through his experiment, he showed that if we have a circuit, any circuit, in which current is passing through, whenever current is passing through any circuit, that current induces or produces some magnetic field in the circuit. That means with this wire, when current passes through this wire, it induces or produces some magnetic field within this wire, and that magnetic field can be seen or can be understood or can be known by using a compass. This was his experiment. So what he did, Hans Christian Ørsted, he did means one day he was doing some experiment with electricity, and by mistake he kept one of his compass on this wire, means he kept the compass over the wire. Now when he passed current through the circuit, when he turned the circuit on, the current passed through the wire, and in the effect, when the current was passing through the wire, the compass needle deflected. Like in normal state, when the circuit was off, when no current was flowing, then the compass needle was showing this direction. Means, for example, was showing this direction. Then when the circuit was turned on, the compass needle deflected and showed another direction of north pole. Basically we know compass needle always points to the north pole and the end of the needle points to the south pole. So in the normal state, means when the compass is kept freely undisturbed, then the needle was pointing north here and south here. But as the current was passed through the circuit, the compass needle deflected, means it changed its direction, and now it was showing north this side or south this side. So basically in our earth, means on our earth, this cannot happen. Like our north pole cannot shift to another place so that the compass needle will deflect or show another north. But a compass needle can be deflected by using a magnet. This compass needle, the needle inside the compass is actually, it is a piece of magnet, and we know a magnet can only change its direction or deflect by using or by bringing some another magnet near it. So with this experiment, Hans Christian Ørsted clarified or got the idea that whenever electric current flows through any circuit, it induces some magnetic field within the circuit. And this was the Ørsted's experiment, which is very popular and it's very important for our daily things which use like motor or a generator, whatever. So this was the first breakthrough in this magnetism era. Means people came to knew about that. People came to knew that magnetic field and electric field are related. Now let us study or know about magnets. First of all, we will know about the magnetic field lines. Now first topic is our magnetic field lines. Now what are magnetic field lines? If we take a magnet, a piece of bar magnet with this side as north pole, this side as south pole. Always remember, magnet always exists in two poles, means magnet always exists in dipole. That means a magnet always has a north pole and a south pole. Even if we break the magnet in two pieces, then those two broken pieces will also have its separate north pole and south pole. If we grind the magnet or we break the magnet into very small pieces that we can, then each small piece will have its own north pole and south pole. That is why magnet is said as a dipole, means it exists as a dipole. Now here, if we take a magnet, small piece of magnet, and put it in a piece of paper, put it over a piece of paper, and sprinkle some iron fillings, means iron powders or small pieces of iron. We spread some iron fillings or put some iron fillings over it. Then these pieces of irons will arrange themselves or put themselves in these two sides. Means they will get attracted, since it is iron. Iron will get attracted to the magnet, and these iron fillings will attract or arrange themselves in the ends of the magnet. They will stick in both the ends. That means these two ends of a magnet has some force or has some capability to hold the iron fillings, and this force or this field of the magnet is known as magnetic field lines. So magnetic field lines can be written as lines of force which emerge from the north pole and move to the south pole of magnet. Magnetic field lines are lines of force which emerge from the north pole and move to the south pole of a magnet. You can write it down. Now, what does this line mean? That means if I have a piece of magnet, north pole, and this is the south pole, then this magnetic field or this magnetic field lines will start from the north pole, move around the magnet, and will finish up at the south pole, like this. And again there will be some like this, like this. They will move from the north and will meet up to the south of a magnet. Means they will move out from the magnet to the north pole and will move around and will come and meet at the or emerge at the south pole. And then inside the magnet inside the magnet, these magnetic field lines will move from south to the north side of the magnet. So magnetic field lines basically move around the magnet. They start from the north pole, move around the magnet and meet to the south pole of a magnet, means for a single magnet. And inside the magnet they move from the south to the north. So this is why the strength of a magnet is mostly located or is mostly present in the north and the south pole. Since the center part of the magnet, middle part, does not have any field lines emerging through it, so this part does not have any kind of magnetic field or magnetic strength. So the strength of a magnet lies on the north and the south pole. These are known as magnetic field lines. Now one very important thing to discuss. For example, from a magnet, some field lines are coming out from the north pole and moving to the south pole. Like this they are moving. So in the path of these field lines, it cannot happen like if one magnetic field line is coming from here and then it is going from this side and intersecting through this part and moving here. That means two field lines, if one field line is moving like this, like for example this is the north pole, this is the south pole, if one magnetic field line is moving like this, then another magnetic field line cannot come and intersect these two. Two magnetic field lines can never intersect each other, because if they intersect in this point, like at this point they are intersecting, so exactly at this point if you put a compass, then this compass will show two directions, so basically which is not possible. So that is why magnetic field lines never intersect. So you can write magnetic field lines never intersect, because at the point of intersection the field lines will show two directions, which is not possible. So you write it down. So magnetic field lines can never intersect, because at the point of intersection there will be two directions, which is not possible. So that is why magnetic field lines always run parallel. No two field lines ever intersect. Sometimes they might not be parallel, the distance may increase or reduce, but they will never intersect. And magnetic field lines can be understood or can be known by using compass. If we hold a magnet and we put compass over the end, this is the north pole, then the compass will direct like this. At this point the compass will direct, and like this the compass will direct in other directions, finally moving to the south pole. So this is how magnetic field lines can be known. This much only for today. Next we will study the current carrying conductor.